Okay, so I'm the user perspective, but I'm also sort of nominally trying to move this thing forward for a number of years. I'll show you some slides. Everything I'm going to show you today is not new stuff. I broke out some slides from 2017, years before Leon was technically part of this process. So to help go through this. So I wanted to talk through this because what I think we're facing is there's challenges of talking about IFC 5 because nobody knows what it is yet, right? Clearly, it's an idea, it's a good idea, but what the specifics are challenging. But I think everybody understands the fundamental reasons why we're going this path, right? From a user's perspective, so just everybody be clear here, I also have the job inside HOK to manage software development, data infrastructure, and help deliver big projects. And at the same time, my role within buildingSMART as a volunteer is to help this along. So I have a little bit of both sides of this thing, and I grew up on a farm, so I know the ag world too, just because of our triple context. So clearly, I think from a developer standpoint and from a usefulness standpoint, IFC is just way too complex. The way it does things, there are 3 people in HOK that know how to crack up on an IFC text file to make manual edits when we need to, but that's not something most people need to do. It's clearly onerous to extend. And you can think of it as a lot of ways from a software perspective. We've had a airport room for, I don't know, going on 6 years. We still don't have specific things. It's in BSDD, but these classifications aren't in the standard, and should they ever have been, or should they ever be, versus just a classification? These are the kinds of things we've been struggling with a long time. And then invariably, the reason I keep doing this is I want something that's an open format that works for what I need. We use it today a lot. We export to IFC for coordination, but because it's pretty much a one-way workflow, it's geometry and properties. It represents some building structure. For our use case, it doesn't do a ton more than that. So over the years, we've collected, certainly we've redoubled this effort to collect feedback. These are the kinds of workflows where we continuously see from people that are, if you will, customers of the end product of IFC, not the software development world. Easy to extend to localize. In my day job, we were working on an airport in Zurich, and Zurich decides they want to express their data on top of IFC in a certain way. It was incredibly hard to do this because it's not meant to do this. So these are the kinds of things. Distributalized, the second line, distributalized is not a word, but it should be. It rolls up all the different use cases of, not everybody is centralized. We have, if you were in the room yesterday, it's always, I think, surprising to the Europeans how legal stuff immediately comes to the top of our interests in North America, maybe in the US more than even Canada. Mexico, I have no idea, but this is a big deal. So the idea of how do we do less work for somebody that's not paying us? Like as a design firm, we can't stand having to model stuff into our models because we own the model. Contractor can't add their own data to it. This is the kind of workflow that actually we hate doing. There's tons of risk in it, so we don't want to do it anymore. So how do you decentralize that process and make it so they can add their own stuff? But the list is pretty clear. Any questions on any of it, please raise your hand. I don't need to talk to you for a half an hour. Any of these things not make sense? Anybody disagree with any item on this list? We always get perfect consensus on what's wrong with our industry and what we need to fix, so that's easy. So the ask is not new. I went back to, good thing Google Drive exists. Back in 2016, we were going through this container process for the fool's errand within buildingSMART. We didn't really have a clear direction, but it was sort of almost, you could think about it, what IFC 5 was supposed to be. It actually comes from a Dutch standard, coins. We were talking about this, but you look at this list and, oh, surprisingly, it's the same list, just expressed in different ways. So this is, from 2016. It's not a, we've struggled with the same things for a long, long time. Some of them are a little bit nuanced to this particular format, which is sort of a SQLite container that reference data inside of it. It's a little little weird, but I think it's probably an ISO standard now for nobody to use. And then we had this list of all the other stuff that people are wanting to put together in their data. And this was a pretty good list. I must have done this on the way to this event because I've never found time to remake this list. But it's just the design, delivery, management, operations of a building is just a collection of a lot of things. Models and properties are just a tiny aspect of it. And now that we have tools such as sort of language models that might even start to help us stitch this stuff together more easily, it's becoming even more of an interest to people. So how did we get to ECS? Because one of the reasons I want to talk about this is just this concept. So we started with what we have now, which is IFC 2x3, IFC 4, which basically people have done all kinds of other representations, but for the vast majority of people, it's represented as a monolithic file. One file, here you go. I think what we learned from is the linked data community showed up before I got to be involved with buildingSMART, so this is probably 2014. And it's a totally different approach. You take this sort of monolithic thing and make it into a graph where every property is a thing. And so you take something that was a monolith and you could think of self-contained, oh, now I have to think about every individual data point as being important, have to manage it. And so they couldn't be farther from apart in implementation perspective. Like they're a crazy world. And so I actually think before we knew what it was, people intuitively understand that different people create different pieces of data that describe the same things. So this ECS idea, which is entity component system as we're talking about, this entity is just the common thing. So this top table has some information about how it's procured. That's a component. It has some geometry component. Potentially, its distance from the wall, if that's what it's cared about. Its location against the floor component. That's really the logic here. It's a very simple idea, but it actually bridges very nicely between these two fundamental ideas of breaking in everything into tiny little data sets versus, well, we should probably make data sets that are logical for people that do real work. So that's the idea of a component, and in actuality, it really just looks something like this. You can decide to look at the arrows. So taking a thing that would have been just the table and breaking it into an entity, and the entity doesn't have any data itself. It's just the components. Questions about this? It's actually, it only gets complex when you try to put this stuff together that some complexity arises. The core idea, I think, is pretty straightforward. Comments, questions, anything? Head nods are good. So when you start to then take this idea like, okay, ECS looks like the right direction. We then have this overlay, which is to say, there are still very basic workflows, right? I want to package some data, I want to send it to somebody, simple. But there's also potentially very, very dynamic, very active, very cyclical looping workflows. And so the real question is, how do you start to think about solving for this many in between? What is the methodology we would go about to solve for these sort of things? So looking at it from, just to be clear, I'm an architect by training. I only can code because ChatGPT exists and it's bad, so it's hacky. So I'm backing my way into becoming a data architect, and I'm bad at it anyway. But you start to think about, like, these are the kinds of topics you have to address when looking at this. And you don't have to address them wholly. You can piecemeal pick these. These are not all of them. But when you start to decide what the solution looks like, we have to understand how these things come together, make decisions about them. And the complexity, I think, is the distributed authoring use case, the one I've described. I'll just talk through it. We're in the US. DPR is a big contractor in the US. They self-perform their own light gauge metal studs. So behind the wall, there's some metal studs. So the idea, like, during design, I provide my my walls to them, they have this recipe for those light gauge studs. Every architect decides we're going to name these 10,000 different ways. Every firm does it differently, but they have one. So they have a enterprise resource planning system that says, well, this is the recipe for that kind of wall. How can I give them my data early in a project? Not all of it, because it's not all there, because it's designed as an iterative thing, but they can attach data to it, and that they don't have to know anything about the instances. Like the individual walls, they can say, every wall that meets this criteria will always have this recipe attached to it. This is a kind of sort of distributing authoring built up in there, which is something to say that it's out of order, right? The ERP system actually existed before I decided to make it a wall in a new design, right? So how do you support this kind of workflow? And there's tons of ways to do it. The real sweet spot is how do we put this together into something that's not overly complex, because we started with something that's complex. How do we take choices from this list and say, prioritize them? And this is an area that I think we've identified all these things, but I don't think we figured out how to make the decisions. It's probably the fairest way to look at this. Good questions. David, you took a picture just because you wanted. I'll give you the slides. Okay. I'm just trying to make sure. Like, I want somebody to. One of the reasons to talk through this is, oh, they're good.
So what's the difference between multi-format serialization and IO?
Well, so multi-format being this requirement we've got from the rail operators that I want to be able to have my 3D data, but I also have SysML data and all these other things that describe my track infrastructure. That is making the linkages between those things. We don't control SysML for track infrastructure, so we're never going to. But the serialization IO is, okay, do you want to bias fast writing out of an application one object at a time, or batch writing to a disk that makes one of those fast? You can make all of these experiences fast. We just have to decide if it's you want to write individual data sets, do you want to batch, do I want to be able to read it faster, or do I make different choices trying to solve different problems? If I have an enterprise data set, do I represent it in a different format if I want to query across 10,000 projects? These are just choices that we have to identify and have to decide. We don't even decide. We have to just identify we're making a choice for prioritization of one of those things. And so I don't think you should take any of this as biasing. These are the most important, but these are parts of the solution we have to think through and decide to solve.
Burying on that question then. Yeah. Sorry, so part of this is that obviously you're saying that not all data is IFC data, which makes perfect sense, right? Is it on us? Is part of our scope figuring out the non-IFC data, or is our scope just figuring out how we would exist in a world with non-IFC data?
Well, certainly I'm of the opinion that buildingSMART doesn't, if it's something we don't control, we should not have an opinion on how it's represented. Maybe we can have a viewpoint that, hey, other standards should evolve. But I think we have to, what's the way to say this? We have to deal with that reality and not make choices that make that really hard. And again, I'm being vague here because it's part of this decision-making process that we haven't figured out. Like what we saw yesterday, I'm shared on the slide, so I grabbed a copy of it. What you immediately see here is I said yesterday in the conversation, the most basic representation of an ECS system. Everything's an entity, it's just dumped to disk. But there were immediately choices made, right? What Leon identified was, well, we decided to use this structure, which bakes in a viewpoint of the data that might be the right one or not, but it is a decision that already got applied on top of it. So it's really hard to make implementations without making choices, which is a challenge. And at the same time, if you look at some of those distributed use cases, it's hard to imagine that one single implementation, let's call this, can solve every problem. So the way I've talked about this, and I'll be quick about it because I'm not going to dwell on this, but we have some choices, which is to say something like the pure standard approach, which is just basically write down the rules. Anything you can represent this way that can represent the data this way with these criteria, it's actually IFC. We don't care. Like, that's the most naive way, but it's actually the most, we don't even provide a serialization. We don't provide a file. These are the rules. We could do that. I'm not advocating we should. But then you could do something a little bit more basic, which is to be something more along the lines of what Posse showed here. Is like he mentioned that you can write to a folder structure, a monolithic JSON. It's a bag of components. It's really what it is. It's not trying to do anything fancy. This one doesn't solve some of the key things we need to solve. So it's not, in itself is not a solution. But doing it this way, you could say, well, that's the default representation. And if you need to represent it in a database or something like that, as long as you get back to this, that's potentially a solution, we could say, right? There's no, IFC is not a representation. It's a default representation. As long as you can get back to it, you're talking about IFC data. There's nuance in there. And then there's we pick an implementation. This is where we start to add capabilities. We have a serialization, and IFC is not only a thing on disk. It's also probably a software library that says this is how you evaluate the data, right? It's much more opinionated. And then clearly you could do a combination of those things. I think forgot an animation. Skip, you don't see the top thing. I think I missed half of these. So I think the observation, I'm just going to show you that slide. The observation is the bag of components gives the broadest application, or you could call it opportunity, right? You can do anything with the bag of components because it is literally just a bunch of components, and you would build things however you want to use it. And so it's the broadest application, but it's the least behavior, right? It doesn't do anything for you. So as you go up this ladder, you get more behavior, but should have been talking to David and Thomas before my mouse. Underneath there's a down arrow that says flexibility, right? Like this is the conundrum when we have such a broad list of things we would like to solve. Potentially, we don't have to solve them all, but there's choices to be made in here, and that's the key example. Well, I'll quickly go back to slides here. Quickly give an illustration of something like, I'm not showing this thing I've called strange matter in the past. This is not interesting. It's just the use case of this. We've prototyped and started using a very generic component-based system internally to solve this specific problem of I need to capture room data for geometry and measurement for machine learning and classification of spaces. Never been a big architecture firm in the US, has never been good at getting data. All my competitors, all of us are trying to solve the same things. We talk to each other. We're all doing this, right? So it's stupid simple. We get two components. One's a geometry and a component that includes measurements. These are made up components, right? They're not IFC components or anything like that. They're just those two pieces of data. We load it into a web page where somebody can classify those spaces. And we write back a new component that adds a third that describes those space. So this is a tiny little toy example of I have a room. It's broken into two data sets. It's only two data sets because we know those, if we are collecting the data live on projects, most likely a few others will change, but not everything changes. So you don't want to rewrite everything. So that's why you break them apart. And then we'll keep adding classifications, and we'll probably make an auto classification service that talks to this database eventually and just applies components to it in the background of what people work. That's exactly a kind of use case for the most stripped down version of this story, because it just breaks it into pieces, and I can have two authoring tools, if you think about it, operate on the same data. So the last thing to think about that, so any component system is software in this world. And we don't talk about it very much, because what I just described, buildingSMART wouldn't be bringing that little service that auto-classifies space, but that's a service I would write against those components, right? I would say, oh, look for these components. If you see them, run this little thing, add a new component. That's a service in this idea. So I think we're hearing that most people are looking at ECS systems for their, infrastructure. The big vendors are thinking that services make up a lot of the knowledge capture that they'll see and add to this data. So there's an interesting question of how much do you put in the data structure itself versus, well, actually, if I have this service and a service can talk to one component, 10 components, 1,000, how much extra overhead do you put in the serialization of the data format versus, write it in code and solve it that way. It's hard for a standards organization that isn't trying to author software to have a real, oh, we're going to write all these services for you. It's probably not what can happen, but it's an interesting conundrum based on where the world is going with web technologies like this. So that was my last slide. Questions for me?
I think I could add something about the system though. Maybe go back a couple of slides to the flexibility and it seems to me that where buildingSMART can step in, everyone will step in for the system, right? Is a simple bag of components is, in my mind, the IFC5 schema, as it were, right? It's here are the things you could do. And what you do is the system specifies, here's what you expect for this workflow, right? If we're still thinking in IFC4 land, right, then a system would specify, hey, somewhere in this bucket, there's going to be a project. And that's going to can get you to everywhere else around here, right? So that would be the specific, you need this project somewhere, right? And I'm not saying that we do, I'm just saying, using that as an example. So I don't see that this is necessarily that we have to choose. Like, I think we can have both worlds because we'll have the specific use cases built on top of the simple bag of components.
Well, and I think that, at least from my perspective, that's the question is, because there's going to potentially many use cases that shape the data in different directions. Well, is everything just, like you said, built on the bag of components? Sorry. Yeah. Everything's built on the bag of components, but that's why the gross little boxes over the arrow is like, oh, because there could be another one there. You potentially wouldn't have any canonical implementation, you'd have multiple implementations.
This is what the validation, these validation services, these are the systems, right? You guys are, or it's an example of the kind of systems that, so buildingSMART is already in this game.
Yeah, I think the only nuance is check work versus do work. Right. My example is once I have a classifier that can look at the database, it actually makes data. Versus the buildingSMART example is just validate. But yeah, they're 100% the same thing.
That's a reasonable division of labor, right?
Yeah. Questions, comments? All the way back.
Yeah, for the key items of the ending to the IFC, for that entry you had about the combined with other. I'm just curious in two parts. Like, one is with some of the new schema entries. Yeah, so on the slide with the key items from the end users of IFC, and you had that entry about combined with other data. I'm curious with respect to like geotechnical, for example, and some of the new directions for IFC 4.4, is that going to get subsumed into the schema? Some of those aspects that are, some of those interests that are currently listed as on that combined with other data line, like are those going to get subsumed into the schema itself? So that's one question. The second question is, do you have any additional insights on how it's being combined? Is that for the submission, or is that like during a given phase in the projects? So just any insight.
Well, so the first one, I think the simple answer is we've had so much scope creep in IFC, we don't want to continue scope creep. We want to, like E57 is a perfect representation of point clouds. Let's not make our own. Let's figure out how to connect to it. Maybe do some engineering on how to say this thing is a group in E57. I'm not saying we should do that, but that's an example. I can only talk to the. I'll get to the slide so it's easy for everybody else to see this, I suppose. I mean, I'll just reference a workflow that we would like to have, and if you stick around for Emma's presentation, you'll see this in spades. In the U.S., for all kinds of reasons, we don't hire the geotech, but we get a report from them. That data is describing specific things about the land under our building. Today, a human has to look at this, go over here and type into a computer that land under my building has this kind of behavior. The structural engineer then says, oh, I have to, I can bear, or I have to put piles in. But that is a chain of thought that is not digital. It's only a human and two data sources. So connecting those things in that example would be, maybe it's just a document reference, or maybe it's actually extracted data. I don't think the important part here is that the singular workflow. It's actually, that's what our industry is.
I think where buildingSMART could step in though is, to be able to say, look, these are the acceptable alternate formats that you could use. So, I mean, you don't want Autodesk creating an IFC5 file where all the geometry is internal Revit geometry.
Yeah, that's not IFC.
Right, but maybe all the meshes are OBJ because we say that's okay.
Maybe I have to scream.
Sure.
Yes, right. Yeah, so I think we have even a much easier line in the sand we can make because these are components, right? We could say only a certain data representation is IFC. Anything else can be there, but that's an IFC or not. And we can, as an organization, decide we don't have to have this. Well, there's standard properties that we define, and then there's other stuff. And other stuff could just actually be also not considered IFC. It's just serialized in the same way.
Right, but I was saying that there's a kind of intermediate, right, where we might say E57 it is okay, right? You can deliver an IFC deliverable that has a Word document as part of it. And that's still a whatever we'd call it, right? Which is, components we created plus components that we're borrowing. You can have point clouds, whatever, right?
Yeah, I was getting another one. Okay. Anything else? This is the easy part of the presentation. Everybody agrees with all the stuff. So
this is what you get when you start recording.
okay.
I'll cut the feed later, and then you'll get the real feedback.
Okay. There you go.
Thank you. So I before we move on, I want to really give a special thanks to Greg, because as he's already been presenting, there is so many people who are providing feedback to buildingSMART about why it sucks and how it can be better. But then they leave, and Greg is one of the only people who actually stays around and does it and brings this to the next level, step by step, keeps on grinding on. So this is indeed a result of 5-10 years. And I've told him before, but I want to tell this on the record as well, that there's nobody else who have brought this to the point where it is now. So again, special thanks. The team has been extended now, but Greg is still very much at the heart of this. So thank you so much for that.